Hello class, today we're going to be learning about solving linear and quadratic inequalities. Okay, I know we've been working with our inequalities for a little bit. We've seen some graphs and where we have two variables, x and y. Today we're going to look at what we can do for solving them for just one variable, or x. So let's start with linear inequalities. This should be a little bit of review. We've seen this before. And it's going to be very similar to solving equations. The only difference is if I multiply or divide by a negative number, it's going to change the value of our equation. Okay, we'll see an example of that in a little bit. But for now, let's treat this like an equation. So if I were going to solve this, first thing I'd notice is I have a couple like terms here, -3 and -6, so I'm going to combine those. So we get 3 is greater than 3x. -3 minus 6 gives me -9. Okay, now we're still trying to get x by itself here, so I want to remove the 9. I can move that to the other side by adding 9 to both sides. So I have 9 is greater than 3x. Lastly, I have this 3 times x here. So the opposite of multiplication is going to be division. And divide both sides by 3. 3 divided by 3 cancels out. 9 divided by 3 gives me 3. So we have 3 is greater than x. If we're reading it from the variable, it'd be x is less than 3. Okay? Now, with our linear inequalities, we get to keep everything we've used so far, distribution, combining like terms, all that's going to hold. What's new this time is if we either multiply, I guess I could try typing this. If I multiply or divide by a negative number, we're going to switch the sign. Okay? Now, the reason that we're going to switch a sign, if we think about it, 3 is greater than 2. That's true. But if I multiply both sides of this equation by, why don't we do times -2? If I multiply both sides of this equation by -2, -2 times 3 will give me -6. We'll leave the sign the same for now. It's greater than 2 times -2 would be -4. But since -6 is a larger negative number, this is incorrect. -4 is actually greater than -6. So what's happening is when I multiply or divide by a negative number, I need to switch the direction of that sign. Okay? Let's see an example where that happens. So let's start by distributing my negative here. -2 times p will give me -2p. -2 times 2 will give us -4. And we still have plus 4p. Okay, let's combine all of our like terms. So I have 20 minus 2p is greater than -2p plus 4p will give me a positive 2p minus 4. Now, I want to get all my p's on one side of the equation. So I'm going to move these 2 p's to the other side of the equation by doing the opposite operation. 2p minus 2p cancels out. So I get 20 minus 4p is greater than -4. Okay, still trying to get that p by itself, so let's subtract 20 from both sides. So I get negative 4p is greater than negative 24. Okay, scroll down a little bit. Get a little more space. All right, now I want to get this p by itself. Negative 4 and p are multiplying, so I'm going to divide by negative 4, divide by negative 4. And notice, since I'm dividing by a negative number, my sign is going to switch directions. Okay? Now negative 4 divided by negative 4 cancels out, so we're left with p. Negative 24 divided by negative 4 is 6. Okay? That's pretty much what's new between inequalities and equations. If you multiply or divide by a negative number, then you have to switch the sign. Okay, so I want you guys to take a second to give this one a try. Let me give you a second so I can give you time to pause the video. Okay, and go. Okay, so we distribute the 5, move all of our m's to one side of the equation, move the constants to the other side of the equation to get negative 14m by itself, divide by negative 14, which changes our sign because we're dividing by a negative number, and then simplify. 56 divided by 14 gives me 4. Hopefully this was a review for you guys. With our quadratics, that's where we get a little bit of new stuff. Okay, so when I'm solving a quadratic inequality, what we're going to do is we're going to get all of our stuff onto one side of the equation, just like we would do when we were solving quadratic equations. So we're still, when we solved quadratic equations in the past, we had a couple methods. Usually we're going to factor, but we also have difference of squares in the square root method as well. But the difference is, once we get our answers, we're going to have to check to see which direction our inequalities are going to be. So let's look at what I mean by that. First things first, we're going to solve the quadratic as if it was an equation. Okay. In this case, I'm going to use difference of squares because x squared is a squared term and 1's a squared term. So in this case, I'm going to use our difference of, I'll even just draw squares. Okay. So we have, as a reminder, our difference of squares. If I have a squared minus b squared, then I can factor this into a plus b times a minus b. So in this case, our a is going to be, our a squared is going to be x squared. So the square root of x squared gives me x. And we have plus, square root of 1 is 1. And we have a minus b, so I have x minus 1. I'm going to take each of my factors, set them equal to 0. So we have x is equal to negative 1 and x is equal to positive 1. Now, this is just like we did with our equations. Remember, back with our factoring. We'll get into some more. We actually have to factor a bit more soon. But what's new, once you have your solutions, what I want you to do is draw a number line. So what I'm going to draw a number line. I'm going to place my two values on it. So I have -1 and I have 1. Once we draw a line, we are going to check points. In this case, they're just a value because it's just an x value. So we're going to check values in each interval. Oh, let me scroll down a little bit. Check values in each interval. So for me, try to pick the easiest numbers you can. Between -1 and 0, well, 0's in there, so I'm going to check 0. So what we're going to do is I'm going to take my value, in this case 0, and I'm going to plug it into the original equation. Yeah, I'll even write that. Plug into the original equation. I'm going to see EO for that. Plug into the original equation. So in this case, I have 0 squared minus 1 is less than 0. So -1 is less than 0. So we're good. This solution works because this is a true statement. So that means our solutions, this interval, that works. These are solutions. Okay? Now, we can check the other intervals. I'm going to pick any number greater than 1. So I'm going to go with 10 because I think that'll be easy to plug in. You could do, or even we'll do 2. Any number that's bigger. Okay? It's the same idea. I'm going to plug that in. So I have 2 squared minus 1 is less than 0. 2 squared is 4. 4 minus 1. Let me extend the page. 4 minus 1, that's 3. It's less than 0. 3 is not less than 0, though. So this is not a true statement. So this is bad. We are not solutions if we're in there. Okay? And now let's check our last interval with -2. Okay? Same idea. Plug in -2 to the original inequality. -2 squared gives me 4. 4 minus 1, that's 3. Quick maths. So 3 is not less than 0. So it's not true. So our solutions are in here. These are the good ones. Those are our solutions. So how we would write this is, I'm going to show you two different ways. We have interval notation. And then we have the one you're probably more used to is our inequalities. Okay, so for interval notation, we include, if we try -1, well, you see how there's no line under there? That means -1 and 1 are not included in our solutions. So we have from -1 to 1, with our parentheses representing the no line underneath, it's not or equal to. So it's from -1 to 1, but not including 1. If we want to write this with inequalities, we have to have that x is going to be bigger than -1 because our solution's to the right of it. So x is greater than -1. And then x is also has to be less than 1. Oop. So we can switch these around to the other side. So we only have to write 1. Okay. So x is bigger than -1, but it is smaller than 1. We read this, -1 is less than x, and x is less than 1. They mean the same thing, they just both might pop up, so you should try to be comfortable with both of them. This is the new concept right here, checking your answers. What's going to be hard for your problems is still step one. Just like when we were doing inequalities with equations, but now we need to check. So, well, hopefully if you guys are strong with solving the equations with your factoring, should be a breeze for you. But if not, well, you're going to get a lot more practice with it. But after you get your solutions, we're going to plug them in to see which intervals our answers are actually in. Okay, so now I'm going to give you guys a problem to try. So pause the video, give this a second, solve the quadratic with factoring, and then just plug your points in to check the intervals. Okay, hopefully you had enough time to give this a go. So first things first, I'm going to divide everything by 5 here, because you notice there's a greatest common factor of 5. So if I divide everything on both sides of the equation by 5, I get x squared, because 5 divided by 5 is just 1, minus 15x divided by 5 gives me the 3, and 10 divided by 5 gives me 2. I'm doing this just to simplify the problem. If you didn't, that's okay, you get to the same place. It's just factoring out that GCF can make it easier for you. Now, to factor it, ABC method, first number, or Berry, I think some like to call it, but if you want a box method, that works too. Breaks down into x minus 2 times x minus 1. So I get x is equal to 2 and x is equal to 1. Draw my number line. The points on there are 1 and 2, and then I need to check each of the zones. Now, I'm picking 0 because I think it's the easiest number to plug in, less than 1. I plugged in 5 because I thought that would be an easier number to plug in, but any number you want to. In between here, between 1 and 2, numbers aren't super pretty to plug in there. So what I'd recommend you doing is check the easy ones first. So for me, I checked the 0 and the 5 first and found that neither of them worked. Both of these zones, no good. Here's a hint. If these aren't answers, the one on the inside is going to be your answer. I'll check the number just to show you in a second, but try to eliminate the easier numbers first. Process of elimination, the last zone needs to be the set of answers. So for us, that's from 1 to 2. This is our interval notation. Or we can write it as an inequality. I have from 1 to 2. Or 1 is less than x and x is less than 2. Just to show you, if I pick 3 over 2, it's 1/2. So it's in between 1 and 2. It does come out to negative 85 over 4, which is less than 0. But we can avoid having to do all of this if we just recognize it's the only zone left over. Another thing, it's either going to be the inside or the outside for your answers. So realistically, if you check this left zone, you see it doesn't work, well, that means the right zone's not going to work either, and the inside's going to be the answer. Just can be quick to kind of do a little bit less work. Okay? All right. Take a second, give this one a go. I'll give you a second to be able to pause the video. Same idea, factor, zap your number line, plug it in. And okay. Hopefully you had some time to try it out. Now, once again, we can factor. I'm using that Berry's method or ABC method. I know some of you have told me you call it that. But first number is a 1 times -6, -6. Break that up into factors. -6 times 1 is -6. Add them together, I get -5. So we have, since this is a 1, I can skip straight to here. If I skip the whole factoring by grouping. So I have x minus 6 times x plus 1. When we solve this, x minus 6 equals 0, we get 6, and x plus 1 equals 0, we get -1. Now that I have my terms, I put those on my number line, so I have -1 and 6 on my number line. I need to pick some numbers in the different intervals, so less than -1, between -1 and 6, and after 6. I picked -2, 0, and 10. And then pick the easy numbers to check first. 0 is pretty much always the easiest number to plug in. So I'm plugging in 0. So I get 0 squared minus 5 times 0 minus 6 is less than 0. 0 squared, 0. -5 times 0 is 0. So I'm left with -6 is less than 0, which is true. Now on the last one, I told you it's either going to be the inside or the outsides. So in this case, it was the inside. So my answer is going to be, if it was interval notation, parentheses -1 to 6. The reason we have these parentheses is because we have this here. If I had a less than or equal to, then my answer would have been the brackets. But I don't have this symbol, so it's just the parentheses. Similar idea for inequalities. The lesser one, x, and then 6. If we wanted to, we could plug these in to check, but since I already know which one is the answer, we don't need to check them all. Okay? Alright, let's do one more. Alright, so now, same idea, except you need to move all of your terms to one side of the equation. Okay? Give you a second to pause the video, give this a try. Okay, hopefully you had a chance to give it a go. Now, we do have terms on both sides of the equation here, but that's not too big of a problem because I can move terms from one side to the other. So just like we did with quadratics when we were solving them, we want our equation to be, in this case, greater than or equal to 0, but we want 0 on one side of the equation. So if I subtract the 3x squared from both sides, I get x squared. That's nice. We have a 1 value in front of here. It's real nice. And I add 5x to the other side as well, just to get all of our terms on one side. Factor, we get our x plus 3 times x plus 2. Set our two factors equal to 0 to find x is equal to -3 and -2. We're going to take these, plug them into our number line. And now I want you to pick the easiest number to plug in. Once again, 0. It's usually going to be 0. Plug 0 in to our equation here. If you want to plug it in the original equation, you can. But I think this equation is just a little easier to plug it into. And since they're equivalent, we can. But if you plugged it back into the original equation, that's fine. Plug it in, we get 0 squared plus 5 times 0 plus 6. So 0 is greater than or equal to 6, which is not true. So this zones out. Remember what I told you earlier? It's either going to be the inside or the outsides. Since it's not the outside, it's got to be the inside. If you wanted to check all of your points, go for it. You do you. But we already know this is going to be the answer. So for our interval notation, we do have that or equal to in the inequality. So we're going to have brackets. And for our inequalities, we have the or equal to on the bottom. Okay. All right. Let's look at one more. To you guys to take a second and give this a try. This one kind of combines what we were doing earlier today as well. Take a second, try it out. Hopefully this one was quick for you. Now, you notice how we started with x squared terms? But if I try combining the x squared terms, they're just going to cancel out. If I subtract x squared from both sides, all the x squareds go away. So now I'm just left with a linear inequality, which are a bit easier to solve. I get all my x's together, so I move the 6x from the right side to the left by adding positive 6x. Okay, and then divide by 4, so we get x is greater than or equal to 3. Okay. Do you have questions? Feel free to ask them in class. Hope you guys have a great rest of your night.